Now that we've talked about literals, expressions, and operators, I'm going to walk you through a small code sample that demonstrates the concepts we just covered. Again, we're going to have a main method, which is going to be a series of calls to other methods. And we're going to start with the method demonstrateLiterals. And in this case, I'm just printing out some literal values to the console. I started with 10, which if I hover over it, it shows that it's an int32, or integer. We also have a double, 3.14. We have a float, which actually shows up as system.single. Floats are converted to system.single. That is the base type in .NET. But don't worry about that. Whenever you're writing C#, you're going to call it a float. 3.14m is a decimal. We can print out the Boolean true, a single character A, and a string hi. And then it's going to pause and it's going to wait for me to hit the enter key to continue, at which point it's going to clear the screen and go to the next method. So here's our program. You can see that all the values printed out. Because console.writeLine calls toString on anything that gets passed in, all of these numeric values in the Boolean were converted to strings, and they were passed right through. Now let's move on to demonstrating escape characters. As you can see here, we're just going to print out some sentences. The first one being, she said, hello, and I want hello to be in double quotes. Since double quotes represent the start and end of a string, if I want to put a double quote inside a string, I have to use the escape character, which is the slash double quote. Since slash represents escaping, if I want to write a path like C:\Windows, I have to double up the backslash character. The next thing I wrote was let's print 3 blank lines after this, /n/n/n. That will print 3 lines. After this, I started playing around with the @ symbol. Remember that if we put the @ symbol before a string starts, it will treat everything in the string as a literal. So in this case, I have @ double quote, and then I go to the next line, write about the @ symbol, and then I go to the next line, and the next line, and I keep tabbing over, and I'm making specially formatted text. And what you're going to see is when this actually prints, it's going to print the text in exactly the position that I put it in. After that, I demonstrate that the @ symbol also makes backslashes literal. So here I've written in a directory structure again, but this time I didn't have to double up my slashes because the @ sign is at the front. So let's bring our program back and run this. And you can see that all the text is printing out as we expected. Now let's demonstrate some arithmetic. In this method, I've got 2 variables that are integers, or whole numbers, x and y. X is going to be set to 21, y is going to be set to 5. I also have 2 decimal values, a and b. A is set to the decimal 21, and b is set to the decimal 5. So both numbers are almost the same, except x and y are whole numbers, and a and b allow decimal places. So the first thing I'm going to do is print out some integer math. And we're going to print out x plus y, x minus y, x times y, x divide y, and x modulus y. And let's see what happens here, because it's actually pretty interesting. 21 plus 5 is 26. 21 minus 5, 16. 21 times 5, 105, no problems there. 21 divided by 5 is 4. When we do integer math, the remainders get chopped off. This is something that's important to remember. If you want decimal places, you have to use double float or decimal. Whole numbers, chop off the decimal. X mod y is 1. Because 21 divides into 5 4 times with 1 remainder. The modulus will give you the remainder. The most common uses for modulus is determining if a number is even or odd. If something mod 2 is equal to 0, it's an even number. You can also use it for other things like finding multiples or finding prime numbers. If I press the enter key, I'm going to do the same math, except this time I'm going to do it with decimals. So now you can see the difference with fractional math. And a divided by b is now 4.2, which is what we would expect doing that kind of division, 21 divided by 5. A modulus b, still 1, doesn't make a difference. Moving along, now we're going to demonstrate our equality comparisons. And this is a very important concept, so take this one to heart. We're going to set x equal to 21, y equal to 5, and z equal to 5. And given those values, we're going to try to determine, is x less than y? Now if x is 21 and y is 5, any 5-year-old can tell you that x is not less than 5. But my purpose is just to walk you through and show you that these expressions will always return true or false. So when I print out x less than y, substitution, and then the expression x less than y, it's going to put the Boolean result in there. And we're going to walk through all these in just a moment. So let's hit the enter key, and here we see y is not less than z. I want to draw your attention to that. Since y and z are equal, it's not less than, but less than or equal would have returned true. Continuing onward, we see our double equal. Is z exactly equal to y? Yes, they are. Is x not equal to z? 21 and 5. Yeah, that's true. So these are actually pretty straightforward. Like I said before, the main thing is just remembering that double equal returns true or false, and single equal assigns things. Now let's look at the conditional operators. In this case, I've written some more complicated expressions. We've got x is 21, y is 5, and z is 5 still. And I've added another variable a, which I set to 0. And I put a little comment here that we can't divide by 0. If you divide a number by 0 in C#, it's going to throw an exception and crash the program. But I'm not going to let it do that, and I'm going to demonstrate why here in just a moment. So given these values, x greater than y, which is true, and x greater than z, which is also true. True and true should return true. X less than y, false, and y is equal to z, true. This is an OR statement. False or true should return true. So let me bring this up and build these here. We see our first one is true. Our second one is also true. Now, here I used parentheses. X is not equal to z. That is true. And x is less than y. That is false. False and true is false. But then I put an OR statement, a is equal to 0. That is true. So we end up with false or true, which is true. So I'm just demonstrating that using parentheses, we can mix and match these ands and ors, and we can make very complicated expressions if we want to. The next line I gave you an example of the not operator. X greater than z, that's true, but I put the not operator in front of it, which will invert it, so true becomes false. Now here's the one I wanted to draw your attention to. X is less than z, that is false, and x divided by a is greater than 0. Since a is 0, under normal circumstances, x divided by a would throw an exception, but not when it's part of an expression that has an AND operator, where the leftmost expression is false. Because we know that in an AND situation, all of the values must be true. When the first value happens to be false, .NET will short circuit the and this statement will not be evaluated at all. It will be skipped. So even though that would normally cause an error, it doesn't cause an error because it never got run. And that's an important thing to remember about ANDs. A lot of times in the future, when we're dealing with nulls, you will see people check for null on the left side of an and then on the right side of an and, command whatever that object is to do something. You can't have a null object do something, so it will automatically short circuit if the value happens to be null. And we'll demonstrate that later in the course. Finally, let's look at the assignment operators. And here we're going to do some math. We're going to start out with x having a value of 1. And then we're going to print out x++ and print out the new value of x. And we're going to move on. I'm going to walk through this with you here. So let's hit enter. Given that x is 1, if we print x++, it sends the current value of x into the console write line, and then it adds 1. So x++ returns 1, but the value of x on the next line is now 2. The next time I print out ++ x, and that becomes 3. X is now 3. So in this case, we incremented x and then printed it. That is the key difference between ++ and x++. The next line I said x plus equals 1. And what that means is take the current value of x, which is 3, and add 1 to it, and store it back in x. So on the next line, when we print out the value of x, it is 4. We can do that with all of the math operators. So x times equals 2. X is currently 4. 4 times 2 is 8. So x becomes 8. X minus equal 1, we're going to take 1 away. X becomes 7. And then x divided by 3 is 2, because x is an integer and the decimal got dropped.